Okay guys, so section 4.2 is talking about area, and that's really what an integral is. So when we talk about derivatives, we're talking about slope, and when we talk about integrals, we're really talking about the area under a curve. But in order to do an area under a curve, we have to understand what these summations mean and how to do them. Okay, so I'm going to start out with this. So sigma notation is this sigma symbol, and it gives me an I value down here and an N up here. Well, that tells me what number I'm going to start with plugging in and what number I'm going to end with plugging in. So in this case, if I'm going from 1 all the way up to N of this term right here, A sub I, that means I'm doing the first term plus the second term plus the third term added up all the way up to the nth term. So what does that mean with real numbers in there? So let's talk about this one, example 1. So part A, this is kind of the easiest type. This tells me that I equals 1 and then N is 6. And this is always how that is, that kind of, that's how it's written, right? That's how they show it. Okay, and then 2I is the term that I'm talking about. That means I'm going to take 2 times whatever I is. So in this case, the first term is 2 times 1 because I is 1. And then plus, so this sigma right here tells me I'm going to add up a whole bunch of values here. It's a summation. So then I'm going to do 2 times 2. Then I'm going to do 2 times 3, and I'm going to go all the way up to 6 because that's what my N value is. So 2 times 4, 2 times 5, 2 times 6. So I am literally going to add all those things up. So this is really 2 plus 4 plus 6 plus 8 plus 10 plus 12. And if I add all of those up, I end up with 42. And you can use a calculator to do that. It's not a big deal. Okay, so this second example, same idea. I'm going to take these values, plug them in for I, and I'm going this time from 0 up to 4. So my first one is 4 times 0 minus 1. My second one is 4 times 1 minus 1. 4 times 2 minus 1. 4 times 3 minus 1. And 4 times 4 minus 1. So then I'm going to simplify all of those. This one would give me negative 1. This one would give me 4 minus 1, which is 3. This one gives me 8 minus 1, which is 7. This one gives me 12 minus 1, which is 11. And this one gives me 16 minus 1, which is 15. And if I add all of those up, I end up with 35. Again, you can use a calculator for those if you want to. Okay, this one is asking me to deal with some fractions. This one is saying put your I value in the denominator and square it. So that means in this first one, I'm starting with 5 and I'm going up to 8. I don't know if you can see how little that is, but from 5 up to 8. So that means my first one is going to be 1 over 5 squared, which I'm going to go ahead and write it as 1 over 25. My next one is going to be 1 over 6 squared, which is 36. And then 1 over 7 squared, which is 49. And then 1 over 8 squared, which is 64, right? So if I put all those together, it actually, my calculator defaulted to a decimal because it's such a weird value. So I'm going to approximate that. I'm going to simplify it to 4 decimal places. I always round to at least 4 decimal places. So mine ended up about 0.1038, and I'm going to stop there. Again, you can check that on your calculator. It didn't give it to me as a fraction because to get that as a fraction, my denominator is going to be pretty large. So it just automatically gave it to me as a decimal. All right, D, this one is kind of the weird one. So this one is telling me now I'm using K instead of I, but it's the same idea. So you're still plugging 1 in for K, and then 2, and then 3, and so on. But this one isn't giving me a stopping point. This one is just saying go to N. So this one is going to be more of a general solution instead of a particular solution. These are all particular solutions because I actually got a value. This one is not going to be that way. So here's what I'm going to do. I don't know what n is, so I'm going to leave this 1 over n. I do know that k starts with 1, so I'm going to plug 1 in first. So this is 3 times 1 minus 7. Plus, then I'm going to do 1 over n again, and I'm going to do 3 times 2 minus 7. And so on. So I'm going to put kind of a dot, dot, dot here. And then plus my last value, my last one over here is going to be 1 over n still. But this last one is going to be 3 times n minus 7 because I don't know what n is. I'm going all the way up to n, but I don't know what it is. So that's like my stopping point. Now, I could go one step further here and simplify this to like 3 minus 7. So this would be negative 4. This would be negative 1. But I don't have to with it being this kind of a messy problem, a general solution like this. I'm really not concerned with simplifying too much. Again, I might make a mistake, so why risk it? Okay. This last one of the summations that I want to talk to you about deals with some summation formulas on page 291 in your textbook. So in my book, here's page 291, and there's this theorem 4.2, which gives me summation formulas. So they're telling me some information about these general formulas. So if I'm going from 1 up to n, and I have just a constant value here, c, maybe that's a 5, then this would be 5 times n. So they're giving me a shortcut to figure this out so that I don't have to worry about it every time. The second situation is, what if I just have an I here? Well, that means I'm going to plug 1 in, and then 2 in, and then 3 in, all the way up to n. They're saying if we simplified all of that, this is what we would end up with. So you can just write it like this instead. That's another shortcut. Same thing here. What if I have I squared? I can plug in 1, I could plug in 2, I could plug in 3, and I could end up with this kind of messy general solution like this. Or I can use this simplified version of it, which they gave me. So I'm going to be smart about it and use theirs if I can. So this one is kind of a weird one. It looks pretty terrible. It has an I squared plus 3 all over n to the third. So what I'm going to do is separate this up as much as I can because I see an I squared there. I know that they gave me a formula for I squared. It's right here. So if I can use this, it's going to save me a lot of time and it's going to make it look prettier. But I need to kind of separate this I squared out from everything else. So I'm going to rewrite this. I'm going to say that this is really, let's see, how do I want to do this? I don't want to make it too messy. I'll put it over here so that this doesn't get in the way. So I'm going to pull out a 1 over n cubed. Separate. Then outside of that, I'm going to do my summations. So outside of that, I'm going to say, here's my summation. And I'm going from I equals 1 up to n. And what I have left is I squared plus 3. So let's write it like that first. But I want to separate this up even more. I want to say this is really a summation of I squared and a summation of 3. So this is the same thing as saying 1 over n cubed and a summation of I squared plus I have a summation of 3. So I have these separate individual things in there. Now I can go back and look at my rules over here. So over here they told me that I squared looks like this. N times n plus 1 times 2n plus 1 all over 6. So I'm going to rewrite this one right here. Get it where you can see it. So I'm going to rewrite this as I've got a 1 over n cubed still up front. And then this piece right here is really that formula that I just looked at. So that ends up this. N times n plus 1 times, 2n plus 1 all over 6. Plus this piece right here, this is a constant, Remember, the constant ends up that constant times n. So this is really plus a 3n. And then I'm going to simplify this as much as I can. All right, so this is really n squared plus n. So I'm going to do this kind of off to the side. I've got an n squared plus n right here. And I'm multiplying that by 2n plus 1. Right, so that's all of this top part. So I'm going to go ahead and FOIL that out. That would be 2n to the third plus n squared plus 2n squared plus n. So all of this top part right here is really 2n to the third plus, if you put these middle two together, that'd be 3n squared plus n all over 6. Okay, well, if that's the case, I can get a common denominator with these two things and combine them, right? So if I want this to have a denominator of 6, that means I need to take this top part times 6. So that means this is going to be 18n over 6. 3n over 1 is the same thing as 18n over 6. So that means I'm taking 18n plus n. That'd be 19n. So really I have a 2n to the third plus 3n squared plus 18n plus n would be 19n all over 6. And I'm going to go ahead and multiply this in too. If I take 1 times that top part, it's just that top part. And if I take n to the third times this stuff, it's n to the third. So I'm just trying to get everything together. And then the last piece of this that I would do is say, let's simplify these n's, because each of these terms has an n in it. So let's take one of those n's out. So that means I have 1 left there, I have 2 left there, I have 2 left there. So that means I have 2n squared plus 3n plus 19 all over 6n squared. So that's simplified, right? The problem is they want me, go back up to your problem, they wanted me to find this for n equals 10, n equals 100, n equals 1,000, and n equals 10,000. So I would then go to a calculator and I would plug in those values. So I would say, okay, now I need to figure out, here's my n values. What do I get from that summation? So what happens if n is 10, if n is 100, if n is 1,000, and if n is 10,000? Those are the 4 they wanted me to plug in. So if you do that on a calculator, plug those in, you end up with these values. 0.415, 0.33865. I kind of left that one pretty long. I didn't simplify that, as I didn't round it to 4 decimal places. You can if you want to. Same thing with this one. I left it 5 decimal places. And then this last one, 33338. So here's what's happening. Let me kind of give you an overview of what this even means. So the higher the n value, the more accurate your answer is. So here's what this means. When I'm talking about, I'm going to talk about this in the next video, but I want to kind of show you what I mean. When I'm talking about the area under a curve, I'm talking about finding a whole bunch of rectangles in there. And then I'm going to add up the areas of all those rectangles, and that's going to give me an approximation of what that area under the curve is. So what they're saying is if n is a higher number, what that means is I have more rectangles. N is the number of rectangles. So if I had 1,000 rectangles in here, that would be a lot more accurate of an area because there wouldn't be all these gaps in here like mine has. So that's a lot more accurate than only having 6 or 7. If I had 10,000 or 100,000 rectangles, that's going to be even more accurate, right? So the more rectangles you have, the more accurate it is. So when I look back at this problem that we just did, these answers were pretty similar to one another, but they kept getting more and more accurate. So this one has the best accuracy. So when they ask me for all of those, that's what they mean by that. But really, you're just plugging some numbers in, and getting those values. So this was my answer on this problem.